Right, absolute value, solving inequality, part 3. So the question here now is, absolute value of x is greater than 3. Okay, so recall from the previous video, if that was to be equal to 3, this would simply mean x is negative 3 or x is equal to positive 3. So this is the representation. Say absolute value of x function, so that's the v shape, and y is equal to 3. So you see 2 points of intersection. But in this question, you're not really are to find where the point of intersection is, although knowing that indirectly helps you to identify the solution, but you need to show when absolute value of x is greater than 3. So looking at the graph, whenever the graph is above that horizontal line, so that will be the set of numbers that would satisfy this inequality. So this portion going up and that, not including negative the 3, negative 3 and 3 at positive 3, because you have to be greater than 3, not equal. So hold on, don't include negative 3 in your statement. So what will be the domain that would make this possible? So anything to the left from negative 3 would make it possible. So any number, like let's say negative 4, absolute value of negative 4, outside solution is 4, greater than 3. Good. So any number that is less than negative 3, or any real number that is greater than positive 3. So 4 also would work, positive 5, anything, fractions, what have you. So how do you make the final statement? X is less than negative 3, or x is greater than 3. Remember, you must emphasize or. Okay, you can't be here and there at the same time. Two disjoint sets. Okay, so this is very important. Now, how would that work in general case? So we can say that absolute value of x now is greater than a. Recall from the previous session that we said absolute value of x is less than a when x is found in between negative a and positive a. So this time, this is equivalent to two separate sets when x is less than negative a or x is greater than a. Very important. Very important. Must know this. So regardless how complex the question is, if you know the fundamentals, you always gonna do right. No question about it. So let's do the example. Supposedly the question is a little bit more complex. Absolute value 2x minus 3 greater than 5. So how do I use this definition here? I have to solve two cases. When whatever goes inside will be less than negative 5. So 2x minus 3, this is the expression inside, must be less than negative 5. Or simultaneously you solve the second inequality. Whatever goes inside of absolute value x, so our x is 2x minus 3, is greater than a, so it's greater than 5. Okay, so you're finding this solution for this inequality and for that inequality. So simplify, 2x is less negative 5 plus 3. So 2x is less than negative 2. So simplify, x is less than negative 1. Bingo. Over here, 2x is greater than 5 plus 3. How do I know this is plus 3? Because you add 3 to both sides, so that becomes 0. So you have 2x on left side. Now the total is 8 divided by 2, so x is greater than 4. So how do you formulate the statement? X is less than -1 or x is greater than 4. So this is my final statement. You can also use interval notation. So you would say x's element of the following interval, -infinity to -1, and union of these two sets, that simply means or, interval that looks like that, between 4 and positive infinity. So the endpoints are not included here. So the number line shows that for the questions above, when x is greater than 3, you have less than -3 or greater than +3. If you were to show the solution on the number line here for this inequality, you have two choices. You can graph 2x minus 3 and then horizontal line and see which part is located above horizontal line, or you can use this solution here and say -1, +4, highlighted this portion, highlighted this portion to the left, highlighted. So why don't I do it? Not including the endpoints. Very important not to make that mistake. Now, what would a solution look like if you were to flip the question? So let's say absolute value of 2x minus 3 less or equal to 5. You already know what is the solution when you're greater than 5. So being less or equal to 5, you probably would be thinking between -1 and +4, including the endpoints. So let's do that quickly. Remember, when you're less than that, you have two cases. Work with 2x minus 3 is less or equal to 5, and see the difference now, and you have to be greater than -5, right? Because you're in between. When you find the solutions of absolute value being less than a number, so you are in between, less than that number and greater than negative value of that number. So 2x minus 3 is greater or equal to -5. Find the solution here. So 2x is less or equal to 8. X is less or equal to 4. Over here, 2x is greater or equal to -5 plus 3, -2. So x is greater or equal to -1. So this is just the complement of that set. So -1, +4, in between. So this is the portion of the line that defines the solution here. All right, thank you very much for watching this video, and I hope that is helpful for you to understand the absolute value concept. Bye for now.